latest best practices. And even if you're up to date on that, hopefully you'll learn some like tools and tricks you can use to make the process easier for you. The slides will be available online. I also have some notes with URLs and links with some more details about some of these things. I'm going to skim over a couple sections. So that'll be online. The URL will be at the end too, so you don't have to worry about capturing it right now. I'm Dave Forgac. I am a developer at American Greetings. I work mainly on a RESTful web API system. Before that, I was a Linux systems administrator, and before that, I worked as a support engineer at a web hosting company. And in all those jobs, I used Python as much as possible. I'd love to get your feedback and any questions you have, so please contact me. This contact information will also be at the end. So about 6 or 7 years ago, I was working at a company in Delaware, and I used a lot of Python tools to do troubleshooting. Some of the tools were installed from the internet using this new tool at the time called pip. But some of them were things that I developed myself or that my coworkers developed. And we found that the ones that we developed ourselves were kind of difficult to manage. We were really just trading scripts around. We had to remember things like make sure to tell the person to make it executable, to drop it in the path. And the big thing we'd always forget is to tell people to install the Python dependencies. So usually what would end up happening was someone would take the script and then try to run it and then tell you this thing's broken, what's your problem? So we'd have to go help them fix it. So that was a pain. So I really wanted to learn how I could make my tools as easy to use as the ones that we installed from the internet. So I Googled, how do I package Python programs? The problem is there was a lot of contradictory advice. Really, there was no clear way to do this. I mean, there were some guides, but if you looked at the next guide, it would say that the other one was out of date and it was wrong. And the biggest source of confusion was which one of these should I use? Disutils, setup tools, and distribute. Again, everyone kind of argued like this is the way to do it, this is the right one. And so really I didn't have a definitive answer. So what I ended up doing was finding a popular open source project, copying it, and replacing their code with my code and their settings with my settings. For the most part, that worked. So I was able to make a package that I could install and I could have other people install. But I wasn't really clear how that worked. But I didn't really know how to go about doing that without doing a ton of research, and I had a job to do. So for a couple of years, I pretty much just ended up copying that repo over and over again when I was doing packaging. But I really didn't know how it worked. So fast forward to about 2013. At my current job, I had the need to make a package that was going to be shared internally at the company. So I decided to research this again. And I found this time that there were answers. The Python community realized that packaging was a problem, and they created a working group called the Python Packaging Authority. They're in charge of pretty much all of the packaging tool chain. So you have like virtualenv and pip and setup tools and PyPI, so all that stuff. And they oversee that now. So that's great. And one of the things that they created was the Python Packaging User's Guide. This was a fork of the old Hitchhiker's Guide to Packaging, but one of the key things they did was on every single page they have a last reviewed date. So you have a really clear indication that the thing you're looking at is up to date and it's authoritative. So this is great. So the rest of this talk is pretty much what I learned updating my packaging using the new Python Packaging User's Guide. So first we're going to go over some packaging definitions. There's a module. A module is basically any Python code saved in a file. This is importable and it's generally used by other modules or the main program that starts up. There's an import package, commonly just called a package. This is really just a namespace. So it's used to organize your code, and in reality, it's a directory with a dunder init.py in it. So that's all it is. But it's used to organize code. And so generally, it's just called a package. Point of confusion, there's a distribution package. which isn't the same as that import package, but this is also commonly called a package. So this is shareable and installable, bundled up Python code. And that's the thing that you get when you download something from PyPI. There are source formats and there are built formats of these distributable packages. The talk is about making those packages. So, then the specific types, there's a source distribution. This contains the Python source code, and if you have any like C extensions, that goes in the source distribution. And when it gets installed by a user, the code is actually run to install it. And then there's a built distribution. The BDIS doesn't stand for binary distribution, it's built distribution. And what that means is it is code that is bundled up in a way that it is just dropped on the system without anything being run. So when you install something from a built distribution, it is literally just copied to the right place in the file system. There's the old built distribution format called the egg that setup tools started. That really isn't going to be supported in the future, so you should not be building those unless you have a really good reason, and that's one of the things I'm not going to cover. But just in general, if you're developing Python code and want to share it, don't build an egg. What you want to use is this new built distribution format called a wheel. And I'll go into that in a little bit, actually right now. Wheel is the new built distribution format that the Packaging Authority created and is maintaining. And there are three types. There's a universal wheel, and that is a file that's installable and usable by Python 2 and 3 and only contains pure Python code. So there's nothing that needs to be compiled, and the same file can be used pretty much anywhere. There's a pure Python wheel, which the only difference is that is just Python code, but it's 2 or 3 specific. And a lot of times, if you have a Python 2 program and you want to update it, you use a tool called 2 to 3. So you build one copy for Python 2, you run 2 to 3, and then you build another copy for Python 3. So that's a pure Python wheel. And then there are platform wheels. Currently, the only supported platforms are Mac OS X and Windows. It turns out all the meta information you need to ensure Linux compatibility is really difficult to manage, and so it's not supported by the current wheel standard. The distutils mailing list has there's a lot of active activity or discussion about a new wheel format for Linux, but it's not there yet, so it doesn't exist. So PyPI, this is the Python package index. This is a repository of Python packages. Anyone can upload to it. And just to be clear, it is not PyPI. PyPI is the just-in-time implementation of Python. So if you're talking about the package index, it's PyPI. So don't say PyPI, unless you're talking about the other thing. So let's look at what makes up a package. These are the components. You can see there's a number of files in like a directory structure. This is what makes up a package. And the only part that's actually your code is that sample with so the sample is your Python code. And the rest is all the meta information that you need to ship a package. And this is from the Packaging Users Guide sample project. So the parts of the module or the package are your code. Obviously, you have code that you want to share, and that's why you're doing this. The setup.py, this is the most important part. This has all the meta information about your package, and it also gives you an executable that you can use to complete your packaging tasks, like building the package, uploading it to PyPI and all those things. So that all runs through the setup.py. So it's really important, and we'll look at that in a second. Setup.cfg is a config file that sits next to setup.py. Right now, it's only used for configuration around that wheel thing I was talking about. But in the future, they're going to be moving a lot of the things that are stored in setup.py to this config file so that it's in a config format rather than in the middle of a program. Manifest.in is a file that has a listing of anything in your package that should be included when it's installed that isn't already Python code or something that's explicitly listed as data elsewhere. And then you want to readme.rst. This is used as like the index page if your project is on GitHub. And some people use this as the PyPI listing information as well. And you can do that by using it in the setup.py, and I'll show you that. Alternatively, you can use a description.rst, and I show it here because the sample project does this. So they use the readme.rst for your GitHub listing and the description.rst for the PyPI listing. And this allows you to separate those things. So now we're going to look at the setup.py in detail. So you see we're importing setup and find packages from setup tools, and specifically setup tools. So I showed you earlier there was distutils, which is in the standard library, setup tools, and then there was a thing called distribute. And distribute was a fork of setup tools, but it has since been merged back. So you want to use setup tools. There are some really specific exceptions, but we're going to ignore those because for your purposes, you don't need to worry about it. So use setup tools. This has really basic information about your package. So the name, the version, a description. These things are listed on PyPI when you look at the package. And then your author information. You want to include licensing information. So you indicate which license it uses. And these things called trove classifiers. That gives PyPI information about where your package can be used. So if it works on Python 2.7 and 3.3 and 3.4, you should list Python 2 and then 2.7 and 3 and 3.3 and 3.4. So that lets people know and be able to search based on what's compatible with what they're using. There are keywords. Those are just used for finding the package in a search. And then that find packages comes from setup tools. And what that will do is it will find any Python code that is in your directory and include it when you bundle it up. But you exclude the docs and the tests. And the reason for that is you don't want those installed in the built distribution. So when you do the built distribution, people don't need the docs and the tests on a production environment. But they would be included if you did a source distribution. So if someone was going to be working on your project, those would be included. Install requires allows you to list any dependencies that you have. So if this project uses requests, you can specify requests. You can also get more specific and specify the individual version, or you can say greater than a specific version. But if you just know you need requests in the basic form, you can do that.
Is that limited to standard library modules?
So the question was, is that limited to standard library? And no, it's not. So if you use setup tools or if you use pip to install the package, it will look at that and it will install anything that's in the dependencies first. And then package data, it allows you to ship extra data with the package. So if you have a thing that does address validation, you might have a data file that includes a bunch of zip codes. So that would be package data. It's not Python code, but it needs to go along with your package in order for the thing to be used. Is there a question?
When would you use package data versus the manifest?
So package data, the question was when would you use package data as opposed to the manifest? Generally, the package data is something that the package specifically uses. So it is a mapping. So the package name in this example is sample, and the package data is package data.dat. And that way you know that that data is needed by that package. The manifest.in is generally used for things like a license file or a README file that you want to make sure get included, even though they're not really code. So package data, the package.dat or package data.dat that you see, that is a relative path to the package name. And then there's this thing called data files, which is used a lot less, but that allows you to specify an absolute path. So if you need to put something outside of the package structure, you can use that. And then there is a scripts directive. Scripts really shouldn't be used unless you know what you're doing, so I would just say ignore it. But it allows you to specify a script that is included that is runnable. But what you should really use is this entry points console scripts. So entry points allows you to specify interfaces for your package. This is most commonly it's used for this console scripts, but it can also be used to dynamically find plugins. So some packages can say that they provide this type of plugin or this type of entry point, and other programs can know to look for things that have that entry point. That's pretty complex, so unless you're doing like plugin development or making your program accept plugins, you don't need to worry about that. But specifically, this console scripts is really neat because it allows you to define a script that will be available in the path, and it maps it to a module and method. So with this definition, in the example, we have hello equals PyOhio 2015, say hello. So what this is going to do is it will create a really small wrapper executable called hello that you can run on the command line, and it will import PyOhio 2015 and run the say hello function. And the nice thing about that is it is platform independent, so it will do the right thing on Linux or Mac or Windows. So on Windows, it'll make like a little batch file. On Linux, it'll make an executable that sits in the path. So that is the just basic package, the absolute minimum. So the packaging guide tries to be really technology agnostic for things outside of packaging. But generally, you want your mature or really just really good package to include these other things too. Really important is to have a license file. Not just specified in the setup.py, but have a license file. People do GitHub searches based on the license, and they'll exclude things that they can't use because it doesn't have a license. So just make it really clear what license your code has, because if you don't specify a license at all, even though it's on GitHub, it's technically not open source. So just have a license. You want to have tests. And even if your project is just a toy and you don't think it's serious, have a really basic test that just imports something and runs something. That's it. I don't care. Just have the most basic of tests. And included with the tests, you want this tox.ini. Tox is a test runner that will run your tests in multiple environments. So this allows you to specify that you want to run your tests in Python 2.6, Python 2.7, Python 3.3, 3.4, or PyPy. It makes it really easy. So I'll show that in a minute too. And the same thing with tests, you want to have documentation. Even just the most basic documentation that says, here's this package, here's what it does, here's the most basic use case. Have that, because you never know when something is going to be, if you're sharing it on the internet, someone might actually end up using it. And if they're using it, they might want to contribute. And if they want to contribute and update your documentation, it's a lot easier for them to do that if a documentation skeleton already exists. But we're going to do that, and we're going to make it really easy for you. You want to use continuous integration tools. So what these will do is they will run your tests every time you update the code. So if this is an open source project that you have on GitHub, I'd suggest using Travis CI. And to do that, you create this travis.yaml file, and you specify, just like the tox, what environments you want the test to run in. And then requirements.txt. This lists all the dependencies of your package, but this is for developers. The install requires that's in the setup.py is for the installation. Requirements.txt lets other developers know what your package needs. And I have a link on those notes that I have online about the difference between those two, and it gets into more detail. And then a git ignore. This tells Git what files you don't want to have source controlled, and generally that's things like in your build directory and compiled things that you want to ignore. And then there's some other files that you should have. You should have a history or changes or changelog so people know what's happened in your project over time. You should have a contributing file so that someone who wants to help has just a really clear set of instructions for how to help, and you should have an authors file to give people credit. So people like having credit for things that they've done for you. So do that, it'll make them feel nice. So let's finally make a package. But not quite. First, we need to install some requirements. So we want to install wheel, which allows us to create that new wheel format. We want to install twine, which allows us to upload things to PyPI in a secure manner. And we install tox, which is that test runner. So you may have noticed that there is a lot of boilerplate, and there's this whole complex directory structure that we have to create to make a package. And that's really kind of a pain. But we're Python programmers, right? So what do? We automate this. Except we're lazy Python programmers. We let someone else automate this. There is a project called cookiecutter that allows you to take a template repo, and it prompts you for input, and then generates an output directory with all those templated files. There are a ton of really good cookiecutter template repos for Python packaging. That was the original intent for this project. Since then, it's gone on to be used for other things. So people use it actually for other programming languages, even though cookiecutter itself is written in Python. So what you do is you take a template repo, and so you make the output. And I have one for packaging. What I'd suggest you do is find one that's close to your needs, fork it, update it for what you need, and then use that as the basis for any packaging that you do. OK, so now we're going to make a virtual env. If you're not familiar, this gives you an isolated Python environment so that anything that you install is only locally there. I use a tool called Virtual Env Wrapper, which kind of helps manage that a little easier. So I'd suggest looking into that. If not, you can use just virtual env or pyvenv if you're on Python 3.4. But I'd suggest looking into Virtual Env Wrapper. They have really good instructions for setting it up, so I'm not going to go into that. And then we run cookiecutter. So the rest of the details aren't really that important. You just need to see that you run cookiecutter and then a repo URL. And it prompts you for all the variables it needs, and then it generates an output directory based on that. So now we're going to go into that directory and do a git init so we can get this thing under source control. And we're going to just commit the thing that was output by the cookiecutter. So we have an initial commit. You do need to have git configured before you do that. So if you haven't done that, that's a separate thing. Now we're going to go ahead and add our code. So this is just the most basic of things. It's going to be a hello world function, and then say hello, which prints the output of the hello world function. And you'll see that I'm using the future import. This is so that my code is Python 2 and 3 compatible. And this allows me to build that universal wheel I was talking about earlier so that a single package can be installed anywhere. I don't have to worry about incompatibilities. I'd suggest if you're going to be developing something new, try to do this so that your code works on 2 and 3. It's a lot easier to do from the beginning than porting something that already exists, although that is still possible and worth your time. And we're going to add that really basic test that I was talking about. And like I said, I don't care about testing every single thing, but just make sure you have something. So this just imports it, runs that hello world, and makes sure that it is outputting hello world. So that's ridiculously simple. So then we use that tox command I was telling you about to run the tests. Now that tox.ini, we didn't have to create that because that was created for us by cookiecutter. So as long as you are using the same versions of Python for your different packages, you never need to change this. You just run tox. And you see in this case, on my computer, it failed for 2.6 because I don't have the interpreter installed, but it passed for 2.7. It failed for 3.3 because I don't have the interpreter installed, but it passed for 3.4. So it's going to run for any Python that you have installed, and it'll give you the error for the ones that don't. This is OK, though, and I'll show you why in a minute.
If you're in a virtual environment, does the tox go out of it to get the other interpreters?
The question was, if you're in a virtual environment, does tox go out of it? And the answer is yes. Tox actually, on the fly, creates another virtual environment and runs the tests in that virtual environment. So now we're going to go ahead and commit that really basic code and tests that we added. And that's it. So now we're going to talk about online services that you should be using to make this all easier for you. Obviously, there's GitHub. You can use Bitbucket, or if you have an internal thing at your company, you can use that. But in this case, we're just going to use GitHub. So we create a package, and since we used cookiecutter, we don't need to include the README or the license or the git ignore because the cookiecutter already included those. And then we're going to add this repo to Travis CI. So this is going to give us continuous integration from the very beginning. It's really easy. You log in with your GitHub credentials, and it just authenticates you. If you've just created a new repo, you need to click the sync button. That was something that got me. It was kind of hidden at the top, and I didn't see my repos, and I was a little confused. So hit the sync button, and then find the repo in question, and just switch it from the gray X to the green check. And immediately, it will start running tests based on what's in there, based on updates to that repo. So now we're going to push what we have so far to that new repo we created. And so GitHub gives you nice instructions for pushing to an existing repo. We're going to go ahead and push, and then go back to Travis CI. And we will see immediately, well, actually within about a minute, the tests kick off. And you can watch this. It'll update live for you. But it'll show you that your tests passed in every environment you have listed in that tox.ini. So even though I'm not testing locally on my laptop with 2.6 or 3.3 because I didn't feel like installing those, I still have the assurance that it's running under 2.6 and 3.3 and PyPy because Travis is doing that for me. So it runs your tests in every environment that is listed in that tox file. And now we're going to sign up for read the docs. So we go to read the docs. It's really similar to signing up for Travis. You link it with your repo URL. And really simply, because we have that cookie cutter that already gives us a documentation skeleton, it will generate really nice looking documentation for you. So we have a README file that gets read in and gives you this home page. We have the contributing file that gets read in and gives you the contributing guidelines, and same thing with the credits and the changelog. So all of that is done for you if you start with a good template. So you have absolutely no excuse to not have documentation or tests and continuous integration for your open source projects, because it's all done for you. So now we're going to go to the package index and create an account. It's just a thing in the upper right-hand corner. You create a new account. You can do this from setup.py, but I'd suggest not doing it because setup.py has a register command, but it does not use SSL. So all your credentials and everything would be going over the wire in plain text. It's better to go sign up online and then save your settings. So you save the settings in PyPI RC file. You can leave the password blank, and if you do, you'll be prompted for it when you go to do an upload. So now let's go ahead and build our package. On the command line, you run setup.py sdist. This makes a source distribution that I talked about and puts it in a build directory. And you do setup.py bdist wheel, and that creates that universal wheel I was talking about that'll be usable on 2 and 3. If you're in a GPG, you can sign the files. This is optional. It gives people assurance that you are really the person who authored it, though. So it's recommended, especially for more mature projects. You register the package on PyPI. And the easiest way to do this is by uploading the package info file that the sdist command generates. So you upload that, and it fills in all the form fields for you. Otherwise, you have to type everything in. And then you use the twine command to upload. And it's really simple. You just do twine, upload everything that's in that dist directory. Then it'll include the signed files if you've signed the packages. And when you do that, you'll see your packages available on PyPI immediately. So now anyone can go ahead and do pip install PyOhio 2015, and they would get your package. And so now that you've done that once, we want to iterate over this. You can install your package in your virtual env using the develop mode. And so that's supposed to be setup.py, not setup.up. So that's a typo. Or pip install-e. And what that will do is it will create a symlink to your source file in the installed packages directory. And this allows you to import the thing, test it, go back and make changes, and not have to reinstall it every time. So you can update your code in the virtual env and see the results immediately just after a reload. So we're going to just make changes to our code. Every time you make changes, you want to increment the version in those two files. So in setup.py and in your init, you should have a version tag. Then we want to commit to the repo, tag the repo with this new version, and push the tags to GitHub. That'll go ahead and kick off a new Travis build. And then you build, sign, and upload again. So you do the same thing. So use the sdist, bdist wheel, and twine to upload. But that last part where we had to update the version in two places and then tag, that was a pain. So I use a tool called Versioneer that allows you to dynamically manage the version based on the Git tag. So when you're in a development environment, it'll read the tag, the current tag that you're at from Git. And if you're not on a tag, it'll add the Git hash to it. And then when you build the thing, it outputs the Git tag to a file that gets read. So you don't need to manage the version anymore. It is stored in the distributions, but then when you're coding it in your development environment, it uses the Git tags. So just a couple caveats on the talk. We didn't talk about things, well, I glossed over a lot in order to get it into this time slot. But there are links for some of it on that URL that I'll show you in a second. Specifically, I didn't talk about any sort of binary extensions. So that's something that's kind of common, is to have C extensions. That makes this a little more complex, but that is covered in the user's guide. And I can't think of anything else. I think I had something else, but that's OK. So like I said, the talk notes and some links are there. That's my contact information. I'd love to get your feedback. So thank you.
Questions?
Hello.
Hi.
So we're all advocates of open source, but hypothetically, if we have a closed source project, how what does and does not work as far as like Travis CI and packaging?
So like at my company, the thing that I did this for was closed source. It's something that's only used internally. We use Jenkins instead of Travis CI to do the continuous integration. But you can definitely Google and find information for building Python packages from Jenkins. And we use Atlassian Stash instead of GitHub. But they're really analogous. So you have the same, it's the same tool chain. You just kind of like pull out pieces and put in like private versions of the same thing. Something else I didn't mention, actually, there is a project called DevPI, which allows you to run PyPI internally. And it can do a couple things. It can either mirror the real PyPI, so you have just local cached copies of the packages that are out there, or you can have it have a repository of just your own stuff. So if you have internal only packages, you can create a DevPI instance and put them there, and then you can use pip install and just base it on that URL instead of the PyPI URL.
So just to follow up to that. So, but then you can still use open source packages within there, so you can have your internal requirements go out and get their needed.
Yeah, you can do it a couple ways. DevPI actually allows you to do a hierarchy thing, so you can have it first search your internal and then go to the internet if you want, or you can just give it an explicit list of packages that are allowed to be in the index and do it that way.
One more jump along those same lines. Internally, we use RPM to distribute our packages in Linux.
Yes.
Is there a way to tie this process into the RPM distribution process?
So I'm actually working on making RPMs for Python things. The tools aren't all that automated right now. There are tools to help you with it, but there's still a lot of manual stuff you need to do.
When I ran into the last time I tried this, so maybe I'll get in touch later.
Yeah, I'm working on that like right now. So
Check out a tool called FPM for that.
That's what I was just about to say.
Yeah, FPM is really good. It lets you make devs, RPMs, anything out of basically any directory.
Get this into the recording.
Yeah, so there's a tool called FPM, and it lets you abstracts away all the package creation for, you can create debs, RPMs, or anything just by plugging in directories. So it can just take arbitrary directories and create packages out of them, and that tool is FPM.
cool, thanks.
I was just going to mention a tool I had heard of that does Debian packages. I think it's DH virtualenv, but I can't
Yeah,
remember.
I've seen that, and actually there's a really good article on that, like that tool chain for doing Python packaging and then getting it. Unfortunately, we use Red Hat and CentOS, so that didn't work for me. But I'd like to do the same thing, but
Any more questions?